Okay, so when I left you in the last slide, we were talking about the sun structure here, and we're not going to concern ourselves with all of these zones, but the core, very hot, where the energy is produced in the sun. The radiative zone, where light is just emerging and trying to go upwards. Then we have the convective zone here, where these so-called convection cells sort of occur, where less dense material rises like this, and then cools when it gets to the surface a little bit, and then when it gets cool, it becomes more dense and then falls back down again, and then heats up and becomes less dense right here, and then rises again. So you get these convection cells in there, in that region. Then, of course, we have the corona, which I'll tell you about in just a second. The solar wind, which is definitely going to contribute to my my proposal that we should start drawing the sun as a mad object like that, not a happy one. And then we have these flares and prominences, which are eruptions from the sun's surface. And the last one that we like to sort of know about just in last two things is the chromosphere and the photosphere. So we'll leave it at that. Those are the ones that we'll concern ourselves with as we go. Okay, so what we see here then is the sun during an eclipse, and I showed you this last time. So this is an eclipse, not last time, but in previous videos. And of course, if you look out here, this white wispy stuff is the corona. So that was on the last slide about the structure of the sun. And this pinkish region right here that you see sort of all around the sun, well, that's the chromosphere. Just another structure of the sun, so sort of a thin outer layer of the sun that looks sort of pinkish like that. So see, there's the corona and there's the chromosphere for you right there. And you can only sort of see the chromosphere and the corona during an eclipse like that. So a couple of nice things to see there. And remember, the corona is the white wispy area. Okay, so on we go then. Here's another very nice shot during an eclipse of the corona. And so I'll just end this sort of introduction to the sun then with a few more facts and maybe just a sketch of our own about sort of the structure of the sun. So sort of course in the inside here is the core, and that's about 1 million degrees, quite hot in there. Then on the outside of the core here, you have the radiative zone. Having trouble squeezing this in here. Get a little bigger here, radiative zone, and this is definitely characterized by just traveling of light from the core to the outside, whatever electromagnetic energy you'd like to think of, whether it's actually just going to be light, if you will, or even if you like to think of it as photons, that's all fine, but that's sort of what's going to be traveling there in the radiative zone, just light in any way you like to think about it, okay? And then after that zone, we go to the convection zone is on the outside of that. So the other layer here, convection. And of course, the correction, as I said last time, is actually where you have the moving mass, actually moving mass is being carried upwards and falls down and carried upward and falls down in that convection cell, those convection cells I was telling you about. Then on the very outside here, you have a layer which is the pinkish chromosphere. And then I was just going to say, as a conclusion for last time, the one that's sort of the easiest one, is the whole big surface here that you see. That's the photosphere. That's the part that you see. So if you want to think about it as the big orange hot ball, that's the photosphere that you can see, and probably the word photo is your best clue in there, because you can see photography or photographs, and you can also see the photosphere. And then, of course, the last one in here is the wispy corona. That's otherwise invisible unless during a solar eclipse. Okay, so there you go. That's sort of the structure of the sun that we'll be concerned with there. And of course, you have those prominences and flares, which are the storms in there. And so just some last minute facts then on the sun, just to get a few things out. Maybe like number one here, the sun is not a planet. It's definitely a star, okay? And so here's something I'll say sort of slowly. It's the only star in our solar system, Now, wait, that sounds a little weird. What about all the stars that we see out at night? Well, those aren't in our solar system. Those are in our galaxy, right? Collectively in our galaxy. But in our solar system, which are a collection of the planets, the inner planets, the outer planets, maybe some asteroids and things like that, the sun is the only star in our solar system. Okay, so it's not a planet for sure. Okay, as far as its composition, number 2 is made of gas, and the gas that it's made out of is mostly hydrogen and helium, although there are some other trace elements in there. And the energy source of the sun here in that core that I'd mentioned a couple times now is a nuclear process called fusion. And what fusion is all about is you take 2 hydrogen atoms, a hydrogen plus a hydrogen, and they sort of react to make helium plus a whole bunch of energy. And so you can think of the helium as a single proton and a single proton. And of course, the helium that comes out is 2 protons and 2 neutrons. So if you sort of look or review your chemistry, that would be the atomic structure of those elements here, the heliums and the hydrogens and the heliums. Then lastly, the energy that comes out is something like 1,000 billion nuclear bombs per second or something like that. Just an enormous amount of energy comes out when the 2 helium atoms the 2 hydrogen atoms come together and produce helium with a bunch of energy. So that is the mechanism inside the sun here, this energy that comes out in the core right there. So the energy is generated in the core, it radiates outwards in terms of light or electromagnetic energy, causes convection cells in the convection zone, which is actually the moving mass moving up and down, and then it gives us everything else we'd expect, a pinkish chromosphere and this wispy corona on the outside.